Hey everyone! Thank you for joining us for the next installation of our AI Apps and Agent Dev series brought to you by NVIDIA. My name's Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Our session is recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our presenters for today. Thank you both so much for joining.
Great to be here. Thanks.
Thank you, Anna.
Yeah, I'll just introduce myself. My name is Brian Benz. I am a principal AI advocate for Microsoft, and I'm going to be doing the demo today and showing a little bit about how you can orchestrate agents to save a lot of time and reliability and money as well. And Don.
And I'm Don Chenard, and I'm from NVIDIA. I'll be covering some of the concepts that you'll want to have clear in your mind so that you can understand what Brian's about to show you. And so, yeah, we're going to team up on this and pull you through it. I've already, I hope that you find it to be worth your while. I want to make sure that all the concepts are clear to you so that Brian can basically pull you through it.
Great. Let's get started. Just going over the agenda real quick. So we're going to talk about how to orchestrate agents in this session. And to get started with that, we're going to talk about how Microsoft and NVIDIA work together, because we're actually demonstrating something that runs on a GPU, on an NVIDIA GPU. So we're going to talk about NVIDIA integrations on Azure, how you can actually work with NVIDIA's GPU infrastructure and our AI services on Microsoft Azure. And then Don's going to cover Nematron models, and I'm going to show you how to actually access some of those for free using a website that's out there. You can access them and use them without charge for dev test, and then of course deploy them later for production. And then we're going to talk about the control plane architecture, including the Foundry Agent Service, which is a relatively new Microsoft service through the Microsoft Foundry. And I'm going to show you how to use GPU agents on Azure Container Apps. So Azure Container Apps, if you think about it, it's sort of like grabbing a node on Kubernetes. And in this case, the node runs on a GPU. And you can scale it up. You can scale it down to 0 if you're not using it. So it's a great thing to use for dev tests and for playing around before you actually implement something in production. And the scenario I'm going to show you is a document processing scenario. I'll get into the details of that in a bit. But it's basically a multi-model pipeline using GPT-4o and NVIDIA Nemotron parser to handle orchestration and parsing of invoices. And I'll show you that in an end-to-end agent orchestration that I built. And we'll get into what exactly that agent does soon.
And it's all available on GitHub, so you can download and play with it when we're done with the webinar.
Yes, I've got a link at the end of the session here to share, and it's got everything on GitHub. Everything works and runs. There's a script for setting it up, and there's a script for running it.
Excellent. Okay, so when you think of NVIDIA, you think, okay, they make the GPUs, and then you think, okay, and those are used in the Azure cloud, so that's all you needed to know. But there's more to the story. So there's lots of integrations and technologies involved. If we look, just start at the hardware level for a second here. NVIDIA has the, the GPUs, the old H100, H200, the latest sort of GB200 GPUs and things like that. If you happen, and so that's part of the platform, that when you're on Azure doing something, you're actually talking to those eventually. You're probably not using DGX Cloud because you're probably not using 100,000 GPUs to train a world-class model, but some people do, just not many. Then other things that are up there are the NVIDIA Omniverse, which is for digital twins and simulations, virtual environments where maybe robots can be trained or manufacturing facilities can be planned, and multiple vendors can come together and you can visualize all of that. That's super important. Now, the thing is that the model is going to get loaded onto a GPU, and the GPU has a certain amount of memory on it. But there's going to be a lot of GPUs involved, each with their own separate memory. So sometimes a GPU is going to find the access on board. That's great. But sometimes it's going to need to go into the memory of another GPU that's in the rack. Right, it's 72 GPUs in a rack. So when it goes to get into that other memory, it's a little longer call, right? And you go through NVLink with slightly more delay because it's not local, right there in your own SRAM, right? The HBM memory that everyone's talking about, right? It's in another GPU's HBM memory. So you got to go through NVLink and go over there and get it. Now, let's say you need to go to a GPU that's not even in your rack. It's not one of these 72 GPUs here. It's in the next rack over. Okay, now you're going to go through like either a Spectrum X Ethernet or an NVIDIA InfiniBand. We're a leader in networking technologies these days. We bought Mellanox a while back, and that was very, very important because we knew that eventually there were going to be hundreds and thousands and millions of GPUs, and you better be able to get from one to the other one really, really fast with all the sort of like inefficiencies of the Ethernet protocol have to get out of your way so that you can get things done quickly. And then when it comes to confidential computing, we've always thought about that in terms of CPUs, but also with GPUs. You load a model down in there. Maybe you don't want people to be able to get to your weights and biases. Maybe those are like the crown jewels of your whole enterprise. So, confident. So we work very closely with Microsoft to make sure that everything's going to be as, confidential computing, right? It's a very, very high bar, serious business. And then when it comes to infrastructure, we developed a little thing called a NIM. A NIM is a container, a Docker container, and it's going to contain an AI model and everything you need to run it. So it's real easy then. If you want to stand up a model, I need this software and that software and then this version of that, and this, days go by and you're still trying to stand up a model. No. With NIM, you just grab the model in a NIM Docker container and go ahead and load it up. If it's small, you can run it on your local computer. If it's bigger, you better be running it up in the Azure cloud on something with some serious heft to it. Now, with those platforms in place, Microsoft, of course, uses those underlying technologies. Everything integrates into it. So when you're using, OpenAI service, right, the Azure OpenAI service, well, that runs on NV200s. And then Azure AI Foundry, you can see the different technology, right? ACA runs on our, can take advantage. Our GPUs can be used in applications that are running under Azure Container Apps. We're in there accelerating things like using our Rapids libraries. Databricks is able to rip through like ridiculously huge amounts of data in a cost-effective and timely way. And all the way down the line to the consumer-facing things such as Microsoft 365 and Teams and Windows. And so there's a lot of integrations to be done. Fortunately, we've been working together for 20 years. So we've got it down. And now in the era of AI, we're certainly not letting up. It's more and more tightly integrating and planning our roadmaps so that everything is the best it can be for you. Next slide.
All right. Yeah, I just want to add one little thing there. I mean, people forget that Microsoft's been running OpenAI on their infrastructure since early days. So we've got a lot of experience using NVIDIA, running on Azure, and enabling OpenAI, one of the first large language models. So pretty cool stuff.
Absolutely. And now we've got a lot of, but you don't always want a real big frontier large language model for everything. Especially now, you have multi-agent architectures, you have mixture of expert architectures. You really want to have a lot of small language models and other types of models like vision models that are smaller and more manageable, and use them together to create these AI applications. So we have introduced this thing at NVIDIA called NVIDIA Nemotron. And people think, oh, well, those are the NVIDIA models. And that's true, but it's really more than just the models. Some of the models are called, Nematron, and there's a whole bunch of other open source models in there for you to be able to, pick up and use. And they're actually, they're really good models. I have some slides coming up on them. Not only do we make the open models available to you, open source models, they're all open source, but also the data that we use to train them. This is actually more valuable than to some people. They're like, whoa, yeah, I hit the jackpot. You can go and just grab those open data sources, use those for, doing maybe fine tuning or distillation, different things that you might want to do. Train up your own model, do evaluations. So lots of uses for the data. We give a bunch of libraries with that as well, part of the Nematron family, and we have a large research department. So there's over 200 research papers that we put up there as well. Next slide, please. Thank you. And so what does Nematron bring to Agentic AI? Really 4 things. The first is we bring those open models, but then moving to the right, it's important to understand that a model that comes from NVIDIA has been highly optimized. There's no one else on the planet that's going to be able to do the optimization like we are. We have a whole department that does this. It's kind of like what I was talking about earlier. Like, oh, it's a close reference to it's in another GPU, it's in another rack, it's in another data center across the world somewhere. So you need to, when you're loading up a model to run it, you need to do lots of optimizations, and we have on all of our models. They're known when you put them up against industry benchmarks for having very high accuracy, leading the leaderboards all over the place. So they're definitely worth checking out. And they're, as I was saying earlier, they're easy to deploy because we make a lot of them available as NIM. Next slide. And so the one you're going to hear about today, Brian's going to be using the NVIDIA Nemotron Parse model. That is in a family of models that we call the visual understanding family of models. But then there's these other families as well. We're not going to go into them today, but I want you to know that if you're just doing reasoning, there's the Nematron reasoning models. We've got the speech models, like leaderboard top 10 slots, 7 of them are NVIDIA, right? If you're doing speech, you want to get familiar with our speech models if you're doing speech, because they're the best in the world as measured by benchmarks. Go out and look at the leaderboards. And then for RAG, very common, people are moving to Agentic, but what they've got, they're either like mission critical. You always want to start out with something easy like a RAG application. So there's a number of different models that we put forward for use in these RAG applications. And then we put forward a RAG blueprint as well to help you if you want to do something like that. And yes, Microsoft has lots of safety things, and we've got our guardrails and some other safety things as well to complement those. Next slide. And so kind of in a summary mode here, and I hand it off to Brian, the Nematron models are bringing to Agentic AI their leading accuracy, their high throughput, the fact that they're open source, the fact that they're enterprise grade. You can get a 24/7, support contract on these things. If a CVE happens, we'll let you know, hey, there was a vulnerability and we fixed it, and here's your new bits, right? I'm on a branch that I want long-term support on, but these other branches have been happening. All that enterprise stuff that it's there, it's in place, and you're going to want that. And the end result is that you'll have faster time to market. So next slide.
Now this is going to be on the quiz. No, just kidding.
Yeah, right. What I did here is the point of this is that It's like better together. So the Microsoft software components that are listed at the top, you're familiar with all of those. You're Azure developers. You live in that world. But I want you to know that there are some things that you should probably learn about from NVIDIA to really, be the best in the industry that you can be. So I've listed them here, and each one, when you get the deck after, each one is a link, and you can click on it. And each link takes you to a web page. And if you click on every one of these links and you read every one of these web pages and blogs and so forth that are down there, you're going to be a genius on what's available for AI on the Azure platform, what you can get from NVIDIA that will make your life easier and make things run faster and more cost effectively. And it can be quite dramatic, by the way. If you go your own and go, okay, these are the things built into Azure that are quite visible to me, and I'll just use these, you can get a certain distance. But as you start to bring in these NVIDIA technologies, you can save yourself a lot of money. So we've got blueprints and we've got toolkits. And then we've got some tools that when you're doing, when you're manipulating data, like Curator and Data Designer and Safe Synthesizer to create synthetic data, right? As well as Retriever that does a number of different operations that you need when you're implementing a RAG blueprint. And then we've got all of our Nematron stuff and an evaluator that now you go, oh, wait a minute. I already got an Azure evaluator, true, but this evaluator is a little bit different. It has, for instance, hundreds of industry standard benchmarks in it and so forth. So it's complementary to the one that you get in Azure. So you might want to use this. It's open source, why not? And then NCG is our catalog. And then for deployment, I talked about NIM. It's a Docker container that makes it easy to deploy a model because it comes packaged with everything it needs to run and then exposes itself as an endpoint so you can start using it. Right? And life is easy. And so other Nemo microservices are tools that you would use in your applications. And our general umbrella for all of our software is called NVIDIA AI Enterprise. Now, if you happen to be in a Kubernetes environment, Run AI will make it run even more efficiently. And we've got a new, when you're looking at your inference server, sometimes it's VLLM, sometimes it's TRT LLM, but it might be a new thing. It could be Triton that's in there as your inference server in the past, but there's a new inference server in town, and that's called Dynamo, and it gives the absolute highest, capabilities. And then guardrails and auditor are in there as well. So that's kind of the, left to the reader, as Brian was saying. There'll be no quiz now, but I just wanted to try and make it easy for you to say, gosh, I'm getting my head wrapped around this. I wish I could just get a map of it. There's your map of it. So with that, I'll hand it over to you, Brian, to, let's see you rip through this PDF and see if you can make any sense out of it for us.
Yes. All right.
You're going to parse the PDF, aren't you?
I'm actually going to start. I'm going to start with something a little bit different, which is this is something I found out on the web. AT&T had an issue, and this is the problem we're going to solve today. They had a problem. They were using 8 billion tokens a day, which is a lot of tokens, and it translates to a lot of money, a lot of energy, and all kinds of things. So they had to rethink their AI, and the way they did it was with orchestration. And I do want to mention a little bit about what a router is. So it's a router or an orchestrator. And basically, when you're talking to ChatGPT, Claude Code, Gemini, all these things, you're no longer talking to the large language model. You used to be talking to the large language model directly way back in the early days. But now you're actually talking to this thing called a router or an orchestrator. And what that does is it decides if the question you're asking is worthy to burn some tokens, or if it can be answered another way. For example, if I say, what's the weather in Los Angeles tomorrow? And I ask Gemini or something, it's not going to use Gemini's compute power. I mean, it's amazing to think that, yes, I have all the knowledge in the universe and you want to know what the weather's going to be like tomorrow. Fine. We don't want to upset AI, right? We'll all be working for us someday. So it's important that we that we are nice to it. Anyway, so the routers are really nice to our large language models. They decide, oh, okay, that's a weather inquiry. I can just go look up an open web service and get the weather for tomorrow. I don't need to use tokens or burn all that energy for a large language model to get the weather, or a math equation or something like that. There's all kinds of other ways you can do things. So that's what orchestration is in a nutshell. And what I'm going to show you today, I'm actually going to show you a live demo. I'm going to run the demo right now, and I'm going to show you what it does. And then I'm going to show you how we did it. So basically what we've got is we've got a, let me just get to that. Actually, first I have to make sure that I wake up my service, and I'll tell you why I have to do this later. But basically, I have to wake up the service, and then I'm going to go into Visual Studio Code, and I'm going to show you what this service does. So it's going to run an agent. It's going to call an agent, and as it's running, I'll tell you what it's doing. But in essence, what it is a agent that gets some invoices. Actually, let's look at those invoices real quick. Sample data. So this is a sample invoice with an anomaly. Oh no, I opened this earlier. Just open it now. Okay, never mind. There's two invoices here, basically. There's two invoices. One has anomalies on it, and they're multi-page invoices. So what has to be done is our agent, our parser, has to scan this invoice, has to pull out the line items for the invoice, and has to figure out if this invoice has any problems with it. And then on top of that, we have an orchestrator. And the orchestrator actually, I'll just run it now. The orchestrator actually figures out if the file that we're looking at is a real invoice first. So it's checking the parser service health I mentioned a second ago, that I had to fire it up and make sure it's working first. And then, oh, okay. So let's try it again. Sometimes I have to run it twice. So what happens is what happens is this application scales down to 0 because it's running on a GPU. So I don't want to run the GPU all the time. It's fairly costly. So it scales down to 0 when I'm not using it. So now what it's doing is it's actually gone out and it's looked up, it's downloaded a PDF. It's converted the page to a PNG image because that's what NVIDIA Nemotron parser uses for image processing and OCR scanning. And then it sends each page to NVIDIA Nemotron Parse NIM API. And I'll explain why I'm using the API in a minute. And then it merges the results from all pages. But the first thing it does is the orchestrator figures out if this invoice is an invoice, if we're not wasting the parser's time on the GPU before we look at it. So it looked at it, it said, yeah, this is an invoice. I'll send this over to the parser. The parser extracted it successfully, and it looked to see what the line items are, and it looked for any anomalies. And it checked 3 rules. One is the total, the sum of the line items. The other one is there any weird pricing in there? Is it outside of the normal pricing for this particular product or service? And then is there any missing required fields? And it detected an anomaly here. An anomaly detected was there's a subtotal mismatch of $97, and there's also another anomaly, which is basically, if we go down here, it's running through the same process. This particular anomaly is the line items are $392, but the total is on the invoice is stated as $412. And there's another one here, which is the unit price for premium support is $250 instead of $42. So it checks for these things, and then it tells you, basically, it runs back to the processor, the orchestrator, and says, look at these things I found, and then theoretically reports them back to either the people who sent you the invoice or someone inside the organization that says, hey, have a look at this invoice. So the idea here is you could have thousands of invoices coming in a day, and you could have them processed with some kind of agent like we have here to decide, hey, is this an invoice that's being sent? Okay, it's a real invoice. We need to check it. Check the invoice against some rules, and then pass that information back to the orchestrator again and say, hey, are there any anomalies? What are we going to do with these anomalies? And basically that in a nutshell is the demo. So
those invoices can be in any kind of format, right? You could have thousands of invoices in hundreds of different formats.
Yes, exactly.
That's why you need AI.
Yes, yeah, they could be anything. In this case, the PDF, we've got a converter that converts PDFs to JPEG. So the Nemotron mentioned, as I mentioned, Nemotron parser only accepts JPEG images. So anything you can fire at it could be a JPEG, could be a PDF, but then you convert it to a JPEG image and fire it over to the parser. But yes, could be anything. So, and the orchestrator will handle that part as well before it actually gets to the parser. So the parser is really good, runs on the GPU. And the reason why we're using the GPU, of course, is because it's really good for, it allows you to parse things very, very quickly, running the parallel processing that the GPU provides. So yeah, so that's just a little bit. So let's go into what we did and how we did it. If I look at the application itself, here's the resource group. So we have a GPU parse agent. That agent is running on Azure Container Apps. And as mentioned before, Azure Container Apps can run on a regular CPU. That's the standard way. And then they run on GPUs as well. And we have NVIDIA N100s and also Tesla T4s for some reason. I don't know why I have those, but we have both of those, and they can scale up and scale down to 0, as I mentioned before. That's one of the powers of the GPU. So think about it like a Kubernetes cluster. And instead of having to set up the whole Kubernetes infrastructure, you're just grabbing one node on that cluster. You're borrowing it for a few seconds, and we bill you for that time you use it. And then you could either scale it right down if you're not using it, or just leave it idle for the next query. And it can run on the GPU. So that's the advantage of ACA, especially for a demo like this. If you're going to go in production, you might want to run on a VM that is continually dedicated to some of the more powerful GPUs that Don mentioned at the beginning. And then we have a multi-agent in our AI Foundry. So inside of the AI Foundry, we have an agent that runs, and that's the orchestrator agent that basically runs the choices for it. So it checks to see if it's a real invoice, passes it to the parser, and then receives back the parsed response and figures out what to do with it. And then we have the Azure Machine Learning Workspace. That's just something that the machine learning infrastructure works on. You have to set up a workspace and then a project. And then inside of that, we've got a storage, because when you're doing this, you need storage to actually parse the images and store them temporarily. And then we've got a key vault. The key vault is something where you can store keys and endpoints, so you can dynamically configure the whole project when you're working on it. You might have, in this case, it's a very simple example with one parser and one orchestrator, but in other places you might have thousands running at once to handle whatever it is you're trying to do with the GPUs and the agents. So it's important to have that key vault for the security there. So one of the cool things we did with that is,
Ryan, can I ask a quick question before you lose me? So
yeah.
So we've got Microsoft Foundry Orchestrator, but I used to talk about the Semantic Kernel. Did that get renamed, or?
We got a new name and a new sort of operation for that called Agent Framework, Microsoft Agent Framework, and it worked closely with Azure Foundry or Microsoft Foundry to run that. Yeah, so that's what we call it now, and that's our new sort of way to handle it.
So we don't call it Semantic Kernel anymore. Now it's the Microsoft Agent Framework.
Right. The math. These things are changing so. I mean, really, let's face it. So it's hard to keep up, but yeah, that's our latest agent framework. And, there's just new capabilities that have to be added all the time. Agents weren't a thing when Semantic Kernel came out. So, it was more, chatbots and things like that. So we've evolved a little bit into the Microsoft Agent Framework, which has more dedicated services and resources for specifically running, securing, and scaling agents. So yes, good question. Thank you.
Thanks.
Okay, so that's a little bit. So what you can do here, we have in our models, in our model catalog, let's go in there to the Foundry. I got to get my project up here. Usually it's there. I could go into the models. Let's talk about how we actually chose the model here. Well, we chose the model because we're working on a NVIDIA Microsoft demo. I just want to highlight that we have 11,373 models we can choose from. And I chose two. I chose GPT-4o. This is the AI Foundry, by the way, folks, who don't know it, ai.azure.com. I always have to back up and mention that. But yes, inside there, we have a model catalog. And inside that model catalog, we have 11,373 models to choose from. Most of them are Hugging Face. I believe, yeah, 10,978 of them are Hugging Face. But we have all kinds of things that you can do with these models and all kinds of contributors to them, including NVIDIA. There we go. So NVIDIA has 29 models in the AI Foundry. And the one we used, if you search for Parse, it's not just that we're working with NVIDIA on this, it's that there's actually one model that works. If I take out the NVIDIA thing even, there's really only three choices. There's a couple from Hugging Face, which is the Wild Wild West. You can try to use them if you want, YOLO. Or you can use the NVIDIA Nemotron parser. And the Nemotron parser actually has the capabilities that we're looking for. Let's get rid of all this clutter. And basically, it tells you it can import text to image, and it only supports JPEG. And it gives you the intended use case. It gives you some sample code and some things you can use. And by the way, I generated the code sample here in Python using the sample code that's provided inside here. And there's some benchmarking here. So the benchmarking is really important. These are what you want to focus on for this particular use, the OCR benchmarks. But there's literally thousands of benchmarks to choose from. These are the ones that we're going to use. Oh, and the vision average, of course. So these are fairly high for OCR. And as you can see, when I do the OCR, it actually works exceptionally well. You saw in the demo, it picked out the line items for the images fairly well. If I look at the sample docs, for example, here we go. Sample data. I think I can look at them in here. So you can see, yeah, okay. So it's Alpine Office Supplies, and it's got the line items, and they're across two different pages, and there's a different header at the top and stuff. So they use these things called bounding boxes, and it works really well with some of the Python libraries I used, and Nemotron parser to return the values that you need into these things called bounding boxes that the orchestrator can use to choose things.
So now, it's like the first call is, what are the bounding boxes? And then there's a call, okay, first bounding box, what's in that one? Next bounding box, what's in that one, right?
Exactly, yes. So it scans everything. But then because it's a Nematron parser, it parses it really well and puts it in the right places so that there are very little errors. In fact, no errors in my demo. That I have run it several times. It gives you the same consistent results all the time, which is great. Not always the case. So it's when you're working with large language models, they can be capricious, but Nematron parse is really, really good. It's been great at figuring out everything, parsing it, and giving us back the values that the parser needs and the orchestrator needs to make decisions. So the other thing we did was we used GPT-4 as well. And the reason we use GPT-4 is because you don't need, I could have used the latest model. In fact, GPT-5.4 just came out late last week. I could use that, but why? All we're doing in this particular case is making decisions based on some parsed data, and an old model that's cheaper and burns less tokens like GPT-4 is perfectly fine for the purposes of this kind of thing. And it processes it consistently. So those two things you need. You need security, consistency, and scalability. We've got scalability through AI Foundry, and if it's running agents and it's calling the GPT-4 a model to run the decision-making part of this, the orchestrator, and then it calls the parser to do its part. So we've got a couple fairly small models. We do not need all the knowledge of the known universe to figure out what needs to be done with an invoice. I mean, it'd be nice, but there's costs involved and all kinds of other things in using the latest models. And it uses a lot more tokens. A reasoning model, for example, uses a lot more tokens than plain old GPT-4 for doing this kind of stuff. So those are a couple of decisions that went into this, the choices. So one interesting thing I do want to mention, we didn't
more
use...
interesting too, Brian, because now you've got one model, the Nematron Parse model, that you've got up and running, and then you're using 4.0 through OpenAI API, right?
Yes, we're using OpenAI API, exactly, and we're running that inside, so it's accessed by an agent, and so everything is secure and managed by those agents, and the agent itself is calling GPT 4.0. So and like I say, it's a big enough model that it does the job and it does it consistently, and the orchestrator level provides the security and the scalability as well. So. Very cool. It's going back to that router thing we were talking about earlier. So the router is the orchestrator, and basically just does a job you need it to do. Now I can deploy this. I can deploy out the parser into AI Foundry. It's going to give me a dedicated model running on a virtual machine. But once again, and this is good for folks who are out there who want to try this at home. I can use this model, I can deploy it, I can set it up in a different location, all that good stuff, but I don't actually need to, because Don was mentioning developer.nvidia.com. I'm going to show something I think is pretty cool as well, and this is build.nvidia.com. So you go out, you can sign up for build.nvidia.com, and you can choose a model that you want to work with. And you don't need to deploy it. You just get a token from NVIDIA. So NVIDIA will send you a token, and you point it to a certain endpoint, and you tell it which model you want to work with, and it will actually go out and get, it will actually give you temporary access to that model to try things out. I wouldn't recommend putting it in production. I'm not sure what the token limits are and stuff like that. For the purposes of something like this, where I'm doing some prototypes, I'm doing a minimal viable product, MVP, and I want to just try things out, I can just get that token from here at buildnvidia.com and deploy this. So by the way, I work for Microsoft. I have to say as well, GitHub Models, and I'm telling you this because it's actually pretty cool. GitHub Models works the same way. So there is the same idea. We have a bunch of models from different providers. Unfortunately, NVIDIA's parser wasn't in there, but you can do the same thing. You get a token, an endpoint, and the name of the model, and you can start interacting with it immediately without deploying anything to test out your application. And one of the cool things they do here is Nematron Parse. They have code that you can use, and that code can just be used. I copy and paste this into my VS Code over here and into ChatGPT, and I can use Cloud Sonnet 4, which I believe is what I have over here. Cloud Opus 4.6, that's the one I was using. And I can actually plug this code in with a prompt, and I can actually just ask GitHub Copilot to generate the code for me. And I actually have the prompts in here. So I've actually shared the prompts I used to generate that code. There was some iteration. It actually needed 3 tries before we actually got the prompt that we needed. And then we used that to generate the code you see here. I am primarily a Java developer, but I was able to write this and build it in Python. And then I had it reviewed by some security agents that we have internally at Microsoft, and everything was fine. So yeah, you can get that out there. So anyway, I digress a bit, but you can actually use that in the build. And once you're ready to go with your application, all you need to do is change. You can deploy the Nematron out to Azure, and you change your token to a key, and you change your endpoint to the endpoint that will be provided when you deploy the model. And that's it. you're good to go. So you can actually deploy this, use the same code, run it on your production image of a Nematron parser inside of a virtual machine, or in this case, Azure Container Apps, to run your code. So that's kind of cool. So that, I think in a nutshell, that covers everything I want to show you there, but we'll go back to the slides now, and I'm going to talk to you about some of the decisions we made with that as well. So what other things to consider, aside from the models you're going to use and the code and how to generate it, and how to set up your orchestration level. We have to make sure that things are secure and that we are scalable as well. And that's what a control plane provides. So what breaks the scale if you got agents calling each other without access control? Well, anyone can call that agent, right? As long as they discover the endpoint. And clouds are notorious for having exposed endpoints from inexperienced developers, mostly that are hacked, basically. So people can start using your model. Someone else can set up a website in a business and start stealing your tokens, basically, with a model. You don't want that to happen. So you need to have a separation of control and execution. Make sure you've got security built in. And then you've got the GPU workloads is another challenge. So we use the ACA with the GPU capabilities instead of a virtual machine or Kubernetes with GPU, because those take a lot of infrastructure considerations and a lot of maintenance and basically overhead to have those working. And then you need to make sure that security policies are applied consistently, and that you have auditable, explainable agent decisions, and you have end-to-end observability across your agents and across your internal structures, including the parser inside of your ACA. So those are some of the things that you have are challenges, and that's why we chose the infrastructure we did. So the infrastructure itself, we put the security controls in. There are tokens between agents. They're scoped. So there's limits actually on how much can be requested per agent. So it's not burning through your GPUs and giving you a big bill at the end of the month. Because the actual parser is reaching out to the NVIDIA build.NVIDIA model, but your parsing is being done on the parser application. So it's actually taking those bounding boxes and breaking them down into something digestible inside of the GPU that you're running on. And then they have audit logging and request validation, making sure that whoever is accessing this GPU that you're running has access to it. It's not just a public IP address. And then you have observability. We have distributed tracing set up through Jaeger, but we also have other tools inside of Azure for doing that as well. And in this case, Jaeger was good enough because it's a demo, but then you might want to use some of our application monitoring tools for managing the end-to-end infrastructure management as well, and improving performance and things like that. You can find out where your bottlenecks are. And then we have the Foundry Agent Service, and the Agent Service provides its own built-in security. And that's what we use for our orchestration, routing, and implementing policies. And then we have the Nematron. In this case, we're using the Nematron parser actually to figure out the. Actually, we're using GPT-4 in this case. This slide's a little bit wrong, but GPT-4 to actually, yeah, we're using that to figure out the classification of the document. Is it an invoice? And then we're extracting things inside of that agent, and the parser is being used to provide whatever gets extracted. Yeah.
So Brian, these agents, they obviously have to run under some identity that's in Entra ID. So do they take on the identity of the person that's using them, or do they take on the identity of some service account?
These ones actually are being used with keys. So
with keys.
Yes, I didn't use the Entra ID specifically for this one because we're going out to build NVIDIA. So we had to pass it some tokens and keys. And when we're running things on ACA, it was just easier to use the tokens and keys to do it. But yes, if everything was inside of Azure, so if we deployed the Nemotron model inside of AI Microsoft's Foundry, then it would make sense to put everything in Intra and set up policies and things. But because we had that little outlier where it's going out to NVIDIA, it was easier to set everything up with tokens and keys. And that's what we've got. So our key vault actually stores a bunch of tokens and keys. And the nice thing about that is inside the key vault, you can change things. So if you want to use Intra ID later. So for folks that don't know, Entra ID is our identity management system inside of Microsoft and inside of Azure. And if you want to just change it to Entra ID, you can do that through Key Vault. So you can actually set that up so that when any one of those components that are listed inside of the Key Vault can also be switched to an Entra ID managed access, as they call it. So all right, so then we've got the document. It gets ingested. They figure out if it's an invoice. It extracts the content. It validates if there are any issues based on those 3 rules that we set up, and then it returns results. So once again, ingesting it, we use GP40 to do the type. We extract things in Nematron parser called by that GPU, and then we do a quality check and we return the results, and their security, as Don pointed out, it's keys and endpoints for every hop, and that's managed by the key vault that we've got set up. Yeah, it allows you to do tracing as well. I'll show that at the end if we have time for that as well, for the tracing. I've got a Jaeger set up, but we also have application monitoring set up as well. So zero trust agent communication, as Don was alluding to. So identity and access, we can use managed identity for the agents, and you can also scope things via tokens. And so there's no shared secrets. There's no hidden information that could be exploited by a man-in-the-middle attack, something like that. It's all managed by the central key vault, so that makes it easier and secure. And
let me just say that managed identities are amazing.
Yes,
I always lose my keys.
This is actually a lot more work to do it the way I did it, but it worked well, and it's just the most flexible thing we could use when we're using that outside service. So yeah, the managed identities are great. It just automatically sets up, and you can give people access inside your org or share access outside. It's great. Yeah. Absolutely. And then we have the policy enforcement and the audit and compliance. Yeah. And let's just go into the, I hope this works.
Now, those policies are policies for the agent, right?
Yes. Yes. Oh, yeah. Over here, policy enforcement. Yeah. So the agent itself, you can set up policies, and that really has to do with access control and scalability and things like that. So if the agent goes over a certain threshold for any one of the policies you set up, you can either have it automatically increase based on rules, or you can have it reviewed by someone to manage any outliers or any issues that keep coming up. So that's the idea. Same with audit and compliance. So you have audit trails and you have logging that's immutable, and the whole idea here is you have compliance for regulations that you may or may not need. In this case, it's an invoice system, so yeah, there might be still issues that come up that you need to focus on for compliance and things like that, even with invoices. Yeah, and then the observability. So we have end-to-end agent monitoring. I think I have I'll show you what I've got. Just a moment. Here we are. Let's have a look at Jaeger. See if we've got anything else happening. Orchestrator. There we go. So the orchestrator is what's actually working right now. We can find traces. It's just got a couple of traces because I ran one earlier. And basically it'll give you the runtime for the orchestrator, and then a call to the parser, and then a pass back to the orchestrator. It gives you the overall timing that you have for each process. And right now we've just got a couple because I just ran it. But yeah, normally you'd have a whole bunch of different things that you could call on. If I look at the Jaeger, everything here, you'll see there's a lot more traces, a little bit of information, but not a lot of information in there. It's just Jaeger running by itself without the orchestrator. So, but yeah, so we've got end-to-end tracing. I didn't set up any custom tracing for this. All I did was enable Jaeger through open tracing, just using an instrumentation key, and we've got the end-to-end if we want to use it. But there's better ways to actually manage the orchestration as well. But I did want to highlight
That's Jaeger. Now, previously I heard about log analytics.
Yes.
So
yes.
Help me understand the difference between those two.
Okay, so log analytics. So we have our own Microsoft offerings. That's what I was alluding to. And Azure monitoring is basically where you can track things, and everything here gets logged. And if you have enough logs, which we don't right now, not much there, then you can actually track them and perform AI processes on them that'll tell you if there's any outliers, if there's anything weird going on. It helps detect patterns and report on anomalies inside of the operation of your application. But yeah, that's essentially what that does for log analytics. So there it is. So Azure Monitor as a centralized metrics and alerts, application insights is a lot like Jaeger. You give it an instrumentation key and it will track things from end to end at the spots you want to be tracked. You can actually set breakpoints and things. Log analytics allows you to use something called KQL, which is Kusto query language for listing queries across agent logs to give you things. And then we've got vendor neutral instrumentation with OpenTelemetry. That's what I just showed you with the Jaeger interface. And we've got real-time agent health views as well. So each one of the performance tools that we have, you can build in. You can go into Azure and you can see the performance of each of the components as well. All right, so I already gave you the demo. I kind of flipped it around. I decided at the last second there to show the demo at the beginning, just to show everyone what exactly was the problem we're trying to solve and how we solved it. But yeah, we're coming up on a few minutes left. I just want to say there's a few things to do. So separate control from execution. So make sure that your security and your agent management is separate from the execution. You can put it all in one app. That's the tempting way to do it. But the way we've done it, I think, is a good model. It allows you to have the orchestrator that basically manages things and decides whether or not it wants to engage your GPUs and your parser if this is a legitimate model. And then the orchestrator receives back the results from the parser's processing and decides if that is something that needs to be handled or if everything's just business as usual, and send this invoice off to your application into your accounts payable system to be processed as a payable invoice. And obviously that's a simple example you could use. We only have 3 rules. There was just, does it add up? Is any outlying? Are there any outliers? And the minimum information for billing on the invoice. But a typical organization might have hundreds or thousands of rules to apply to each invoice. So it takes away a lot of the manual processing, and it's reliable and secure. So that's kind of nice. And you can use open models, and that gives you the production quality. As I mentioned before, you don't need to use the latest model all the time. It's great to do that if you're doing things like when I'm generating code. I want to use the latest model, and I'm using Cloud Opus 4.6. And by the way, that's a good thing to mention. We have all of the latest models available in VS Code. There's all this talk about one model eating another model's lunch, et cetera, et cetera. We have them all. We work with all these vendors and all these model providers to make sure that our models, that our experience for our developers is the best it can be. So GitHub Copilot always has the latest models in it for generating code, but you don't need that for this agent. For this agent, you're really just
policy, because in the world of AI, Like we get this all the time. Like we're on the top of the leaderboard, and then the next day it's like we're not anymore.
Right?
Like, did you enjoy it for 24 hours? Was it fun being king of the hill for
Exactly. Whoever the latest popular models are not going to be the latest popular models in a year. People will figure out how to do something better, and that's kind of the way it is.
Rapidly evolving.
It changes so fast. You're great. Example of the semantic kernel versus the Microsoft Agent Framework is a great example. I mean, it's you blink and you miss it. It's gone. It's next is the next one is available. So, and that's us adapting to the marketplace as quickly as we can. So, if you have a new model you've heard about, it's cool. Go into GitHub Copilot if you have an account, and sign up if you don't, and just check your models. You probably have it already in GitHub Copilot. You can try it out, and if you don't like that one, you can switch back to the one you were using before. So,
that's why it's important. And with NIM, right? We expose it as an open AI and open API compatible endpoint, right? That way you can swap them around without too much trouble.
Yeah, that's a good point. We have a couple of minutes left. Let me show that real quick. That is an excellent point. Just as we're going through this, let's go into the Foundry. And if I choose GPT 4.0, oops, GPT, come on. Where is it now? I don't see. But anyway, if I choose GPT 4.0, if I choose actually any model, so let's go back to all the models we had to choose from, all back here. Now I go into 5.4 or any of these models. It gives you, once you've deployed them, GPT 5.4 is not letting me deploy. That's oh, here it is. Once I deployed it, it actually gives you code samples that you can use to. It's a live demo. It's not a very good live demo here, but if I actually deploy this, once it's deployed, you'll see code samples that you can use and tips and tricks for actually interacting with the code. So it'll actually give you the starting blocks for working with whatever model you're working with. And back to your point, Don, there's a drop down in there for OpenAI, Azure OpenAI, AI inference infrastructure, things like that. So there's different SDKs that you can use depending on your needs. And the two that are mainly there are OpenAI and Azure OpenAI. OpenAI has the most recent stuff if you're working with that. And OpenAI is not necessarily limited to OpenAI models. It's a little bit confusing, but OpenAI Claude actually has adopted OpenAI's infrastructure for formatting for SDK. So if you have OpenAI and you want to use a Claude code model or Claude Opus, for example, it's basically the same code to access that as well. So that's the idea. And then there's other things on top of that. There's LangChain for Python, JavaScript, and Java. These are frameworks that you can use to sort of abstract the connection to your large language model as well. So you can easily swap them out behind the scenes, and the code you've written or generated these days will work the same. So, yeah. So open models, production quality. Make sure that you're using those open weight models, the ones that that we talked about in this particular case, and use the model for the job. So in this case, NVIDIA Nemotron Parse is a good niche, as you can see, from 11,000 models that we had to choose from in the Microsoft Foundry, or that there was only 3 to choose from, and NVIDIA was the only name brand model, the one that has been, vetted and considered somewhat reliable, of course.
It's a much harder problem than I thought it was. I was talking to the developer and I'm like, there's lots of parsing models out there. Well, what are you doing? He's like, none of them work, Don. None of them. They all fall down. Yes. And it was a really hard problem to crack. Yeah.
It was. Yeah. I mean, I'm very impressed. The OCR, I mean, I showed you the benchmarks. So the best benchmarks were 74. So 74, I don't know, believe that. So 74% accuracy. I heard
That means you're
actually, I heard
working
a
all
stat.
weekend to fix it.
You want to hear this stat? So for developers who are generating code, statistically, Claude just recently put out some benchmarks, and they have the best model at, guess what, 30%. So that means that 30% of the time, the model will work the first time. It's only 30%. Of course, a year ago it was 4%, but anyway, 30% is still, if you try to generate some code and you've been blown away with it, just remember that's only 30%. It only works for the first time 30% of the time. So interesting. Anyway, so let's wrap up. We got a couple of minutes left, but yeah, so open models, production quality, pick the right model, and don't be afraid to use older, cheaper models, depending on, just think about the task you're trying to do and figure out if the task you're trying to do has, it needs all the knowledge of the universe to do it, or it can be specified.
Or smaller models. Maybe you want to take a large, expensive model
Yes.
and have it create a data set for you
Yes.
that, it has the, it has the prompt and then has the answer, right?
Mhm.
And then take that data set and divide it up and use distillation to train a smaller model using that data set. Of course, you divided the data set, so you can train with 80% of it and then test with 20% of it. And in the end, you've got a small model that's like pretty smart. And so it's running at maybe a fifth of the cost of the big boy and giving you maybe a lot of what you need there. Can make a big difference. So AI applications now are all about orchestrating, 2, 3, 4, 5, 6, 7, 8 small language models, some of which have domain expertise. Obviously each one of them have domain expertise that's particular, and the orchestrator knows what to give to who.
Exactly. So hence the purpose of our presentation, to talk about the orchestrator, because that's becoming more and more important, that router, that orchestrator, to make things work. So I'm just going to skip to this is the final slide. We're at 1 hour, 1 minute. So yeah, resources and next steps. Please do check out aka.ms/Microsoft NVIDIA demo. The slides that we just threw together, the slides that we just the final assembly of the slides, let's put it that way, that we just finished, I will post there immediately, and it'll be available, and all the code. Please do check this out. You can run this with an Azure account, which you can get for free. And you can run this with NVIDIA Builder account, and you don't need anything special. The GPT-4o is a pretty low-end, cheap model to use, so it's not going to cost you a huge amount of money to try it out on Azure. And the NVIDIA one is free. In fact, if you really wanted to hack at it, you could use GitHub models for GPT-4 and not have to have an account at all. Do check those out, the GitHub models.
That's what I was thinking as you were talking, Brian. I'm like, yeah, try it out and then swap it out.
Yeah, you can do that exactly. So it's there. Yeah, fork it, star it. Please do let us know how it goes. And thanks for joining us today. Yeah.
Well, I certainly learned. Thank you, Brian.
Yeah. What was that? Sorry.
I said I certainly learned a ton. Thank you.
Likewise. Thanks.